Hello all, welcome back to A Gap Logics. In the previous class, we have discussed about the time data type, which is the other data types, time, and we have discussed about integers. Okay, so in this today's class, what we are going to discuss is all about the real data type. A real variable can store floating point values and can be assigned the same as integer and range. Okay, a real variable is actually able to store the floating point values. In the C language we call it as float or double or any long double, like this. But in this case of Verilog, there is no data type like float. Data type named with float uh, which stores um, decimal point values in case of C. In case of Verilog, we call that same data type as real. Okay, float in C is equal to the real in Verilog. For your better understanding purpose, I am going to say like that. So how to declare, what is the syntax? So you can see over here, this is the code 15, which is a generally it's actually in syntax. First of all, we are going to give the data type name. After, we are going to give the of variable name and then semicolon as usual. Similarly, how we assign for the integer and range, we are going to assign or the declare the variable same like them them only. Okay, yeah. So this is all about the real. Now with the practical approach, we can discuss some points regarding real, like we have discussed previously in case of integer and time. So you can see over here what are the by default value, what is the by default size of this particular real variable. We can see all of this now for the real. Okay, yeah. So for that, let me write a code for you. Yeah, yeah. You can see over here I have declared a module of name real data type, and in that module I have declared a variable named float, which is the type of real. So I have taken initial begin block to display what is the value that this particular float variable is stored uh, before we initializing this particular value to this particular variable to a uh, value. So let us see, after declaration without initializing, let us see the what is the value. Okay, so that I have taken initial begin block, and in initial begin block I have written dollar display statement, and this dollar display statement is like a printf statement in the C. Okay, float equal to percentage 0f comma float, which is a variable. Percentage 0f is the format specifier that we have used. I have started begin and I have to end the begin statement, so that I have entered it. And I also have started module real data type, so we need to end this particular module, so that I have used the end module. So before executing this particular code, let me comment these particular things. Okay, till this point. Okay, let me comment till this point. Okay, this is the actual code, right? This is the theoretical matter that we have discussed previously. So okay, let me run the code by saving the code. These are the comments to run this particular code. Two comments. Okay, yeah, you can see over here we got the value float equal to 0.000. How many zeros we have? 6 zeros, right? After decimal point it is precision 6. Okay, after decimal point it's the precision 6, right? So let me show you output. Okay, yeah, this is the output for the code 1. So let me show you, and you can also, what we have to guys need to observe the point is by default, before initialization after declaration of the variable. Before initialization of the variable, we while printing the variable value, we got the 0.000 up till 6 zeros. It means the precision is 6. And the other point you need to remember, need to observe in this particular code is, so by default real data type can store the, by default real data type variable can able to store 0.000 value. Okay, by default its value is 0.00. In the previous case, if you're going to see over here, I have given um, the points, right? So let me write these points as well for this real data type. So points should be remembered for the real data type. For the real, by default real data type can store the value 0.0. Okay, 0.0 in this case, we got 6 zeros, right? So anything, you can take it as anything, 0.0 or 0.06 zeros, anything you can able to take. So let me discuss these 2 points as well, which is by default real can store how many uh, bits, and by default whether real is signed or unsigned. Okay, let me discuss this point as well. And the format specifier that we have used here is %0f. Okay, so let's see, you can change the precision as well, in the case of how you going to change precision in case of C language. You can also change this precision. Let me show you that point as well. So let me copy this code. Yeah, paste it over here. So if you are going to keep here in the point format specifier 0.2, it is the, it, what does it means after decimal point print only 2 digits in the output. It's the meaning of this particular 0.2f. So let me save this code and rerun this the code. So you can see over here we got the float equal to 0.00. We got only two zeros after the decimal point. Okay, yeah, you can set that precision value. Okay, so let me show output for this code. So I'm going to paste over here. So let us see what, let us see, just a second. Yeah, let me cut this. Next, you can also able to change this particular value precision to some other greater than 6. Let's see why, because by default we got the precision as 6. Okay, after decimal point we got the 6 zeros, right? So I'm going to take it as greater than 6 and save this particular code and run the code again by running these two commands. Yeah, I got an error, I think so. Let me see this, the error. So syntax error. Okay, yeah, I got the syntax error. Why? Because here the I didn't comment this particular line output float equal 0.00. So that I am going to rerun this code again. Yeah, if you're going to rerun this particular code by saving this code, let us see what happens. Sorry, yeah. So I got after 0.9 zeros. Okay, whether the precision greater than 9 or sorry, whether the precision greater than default value, that is 6, or less than 6, you can print after using this 0 point, how many zeros you need, that you have to place over here in place of 9. In the previous class I have placed the 0 0.2, right? Yeah, so this is how you're going to change the precision after decimal point. By default it's 6 if you didn't mention any precision. If you want to mention the precision value, you have to use it as 0.2 or 0.9 or 0 point any value. 0 point how many zeros you want, that much value we have to put it over here. Yeah, and the next thing that I'm going to do is uh, let me comment this as well for the final review. Yeah, the next thing I'm going to take, I have taken the same code as previous. Now I'm going to assign the variable with a value. So I'm going to assign some 9.00076, something like this. So let me save this code and it again. So you can see over here it's only getting the 6 precision value, that is 9.004076, and after those after the 6 the values are getting discarded. Okay, yeah. So let me assign some negative value to it, some 90 point minus 50.0000, like this. Okay, I have assigned them negative value, and let me run the code again. Got minus 50.0000. We got the same value. Okay, yeah. So uh, by this what you can able to say is, you got while you assign the negative value to the variable float, which is a type of real. When you print the particular value, we got the answer in the negative form only. So by this you can able to say that the real is a signed. Okay, by this you can able to say is real is a signed data type by default. By default real is a signed data type. And also one point I have discussed previously, that is by default real value is 0.00. These 2 points have been covered, and the format specifier that we are going to use is %0f. So why real is signed? Did you got this point? Why? Because I am assigned the native value to the variable float. So if this particular float or the real data type is by default unsigned, then the value, this minus 50, should be converted to the twos or twos twos or tens complement. Okay, yeah, maybe twos or tens complement, and then it should be print as output as a positive value. But instead of that, it simply printed the same negative value in the output, which uh, tells us that uh, real data type is a by default signed data type. So let me put uh, unsigned over here and check the output for our better understanding purpose, whether we are going to get minus 50 or any other value. So there is one mistake that I have done previously so many times. That is, I also told you guys, so you shouldn't use the modifier in between data type and the variable name. So you have to use in front of the data type name. Okay, so you have to use like this. So let me save this code and again rerun the program. So sorry, I haven't run. So again I got the error. Again I got the same error, invalid module item. May check this. Yeah, yeah. Well, we can't able to use the modifier, I think so. So that we didn't getting any value in the output. So I think you guys check it once and tell me if you guys know about this. So I will check it and re-verify and will tell you. And our last agenda is to uh, know how many bits the real data type can store. Okay, for that you have to take an integer, and I'm going to take a variable number of bits, okay, which is equal to, I'm going to assign dollar bits of dollar, which is a system task, this bits of float I'm going to use, and I am going to use another display statement, which is dollar display of number of bits, number of uh, bits that the float variable float variable can able to store. Okay, yeah, let me use percentage by, because I have used the integer data type and the number of uh, bits. Okay, yeah, let me save this particular code and rerun this particular code again. Yeah, we are going to check the by default, right? By default we need to check it, right? So I'm not assigning this in this code. I'm going to take another code. Okay, yeah, let me remove this and let me copy the same code and paste over here again, and remove this dollar display statement in the previous. Okay, this is one type of code, and let me comment this particular code. Yeah, just a second, you will get in clarity. So yeah, so have removing this particular value. Why? Because we are going to check how many bits the by default it stores, and so I'm going to use the system task here itself. So dollar bits of what is that variable name, that is float, right? So let me save this particular code and rerun this the code. Yeah, you can see over here it's getting one, it's getting one. I think it's wrong. Let me remove this variable name and again use the data type itself. So let us see how many bits. So it's getting error, so let me check it, just a second. Yeah, well, I think the simulator in the VS Code is different. It's showing output as one, you can see over here in the VS Code. So let me, this is the code, this is the same code. uh, yeah, this is, yeah, this is the code, you can see over here. I'm going to run. I got an error. Yeah, I got an error over here. And if I'm going to use a float over here instead of data type, so you can see I'm getting one as the output. Let me save this particular code and rerun this code. uh, just a second. Yeah, you can see over here number of bits that the float variable can able to store equal to 1. I think it's because of the simulator or the uh, because of this used simulator or the VS Code. I don't know what might be the reason is showing like that. So that I have went to Media Playground and pasted the same code that I have written over here. You can see over here, pasted the same code, and I'm going to run this particular code. Already the code is saved, so I just running this code. So let me show you output. You can see over here output, number of bits that the float variable can able to store is 64. Yeah, the same code showing 64 in the EDA playground by using this particular simulator, first one. Whereas in the VS Code, where I have used, I think, Verilog, yeah, Icarus Verilog I have used there. In the VS Code is showing some different as 1 bit. So it's depend upon the simulator, but actual the answer is 64-bit. Yeah, you can go with the EDA playground. Yeah, is it okay? Yeah. So I think let me wind up this session by uh, summarizing the points. So let me do that. Yeah, just a second. So you can see over here by default real can store 64-bit. We have seen that by using this particular code. Um, yeah, and by default real value is 0.000006 zeros that we have got from this particular code. Okay, yeah, first code. And by default real is signed. How did we told this? By storing the uh, float variable, which is a real one, uh, with minus 50.0000. While printing this particular value, it's getting printed like the same number, that is minus 50, instead of printing a positive number by taking 2's complement. If we take it 2's complement and print it, then we can able to say that it is an unsigned by default, but it simply prints the same negative value without printing any positive value, so that we can able to say that the real data type is signed by default. And format specifier that we use it over here is pastel 0f. So that this is all about this particular video. In this video I have discussed about the real data type. So I think you guys able to understand what how the real data type works and what are the default values of the real data type. Yeah, that's it. Instead of watching this video blindly, I recommend you guys to have an hands-on experience by uh, executing or the simulating this particular codes in the EDA playground or the like this VS Code extension. So the thing is, why I have used VS Code extension, because it's better to store the notes over here in the VS Code itself, so that I have been using the VS Code. So if you also like me to store the notes, if you're also thinking that to store the notes like me, then you can also use this VS Code. But you're going to see, right, we are getting some errors in the VS Code, so I prefer you guys to execute the code in the EDA playground itself. Yeah, yeah, that's it all about this video, and thank you guys. If you're watching, if you like, please like, share and subscribe. And yeah, there may be confusing in the coding. If you're not confusing in the coding, then you are nothing, you're learning nothing. Yeah, you must be confused, and you have to be clarity also. You have to get clarity at the end of the day. Yeah, I hope you got clarity about the real data type, and also what I have discussed in this series till now. I hope you got the clarity. Yeah, that's it for this video. Thank you guys. Bye.